Good morning, kids. We are on 1-2 remembering today, and you're going to see some simple addition and subtraction with thousands, 10,000s, and 100,000s, and you are also going to see a fraction bar that we practiced on Monday, Tuesday, and Thursday, and some simple fractions, which are just adding unit fractions and fractions with common denominators. And we do not do stretch your thinking, so you can put some lines through it or an X through it before we get started. I'll go ahead and do number 1 with you for a review of your addition problems. And we have 4,560 plus 52,973. When you're adding multiple digit numbers, you need to make sure that you line your numbers up. Really, by the time you guys are working on these, I know you've been reviewing this for years, but the times that I see mistakes, it's because people kind of write them sloppily or they don't line them up. So we're just going to add straight down. 0 plus 3 is equal to 3. 7 plus 6 is equal to 13. Put down your 3, carry your 1. 9 plus 5 is equal to 14, plus 1 is equal to 15. Put down your 5, carry your 1. 4 plus 2 is equal to 6, plus 1 is equal to 7, and 5 plus nothing is 5. So your answer is 57,533 for number 1. I believe you will be able to manage 2, 3, and 4 on your own without support. We have a word problem for number 5. It reads, solve the problem below by circling parts of the fraction bar. Write the appropriate equation below the bar. Molly is driving across country. She covered 2/10 of the distance on the first day and 3/10 on the second day. What fraction of the distance did she cover on the first 2 days? So we're looking at the first 2 days, and that means we're looking at an addition problem. First, we're going to go ahead and write down our equation. And we know it's an addition problem, so our equation is 2/10, which she covered on that first day, plus 3/10, which she covered on the second day. Remember, the denominator in addition problem needs to be a common denominator, which it is. They're both the number 10, so tenths, and that stays the same. So the denominator stays the same, and you simply add straight across, and 2 plus 3 is equal to 5. So 5/10 of the way is our addition problem. I want you to remember when we talked a little bit about reducing our fractions and 5/10, okay, we know that 5 can go into 5 and 5 can go into 10, okay, so 5 can go into 5 one time and 5 can go into 10 two times, so really 5/10 is equal to 1/2, which means those are equivalent fractions, and 1/2 is the reduced form. For the second part, it asks us to circle the distance on each. Well, I need to first circle the first day. She went 2/10, and you could color it in or circle it. Coloring it in might make a little more sense to you. And on the second day, she traveled 3/10 to 3/10 of the way. And then you could simply count up what you've circled. How many boxes did you circle? 1, 2, 3, 4, 5, and check to make sure that you're correct. And we are 5/10, and 5/10 is equal to 1/2. Number 6, 7, and 8 are great practice for you to do independently, so I'd like you to work on those 3 on your own. 6, 7, and 8, those are review from what we've done before. And number 9, 10, and 11, I'm going to talk to you a little bit about, and I'm going to do them with you because they look a little different. Same type of problem, just asking in a different way. So if we look at number 9, it says 8/10 plus, and it's blank, is equal to 1. And what is it that we need to know? Well, 8/10, okay, is a fraction, and we could even go back over and use this same fraction bar because it's in tenths. So without even having to draw one, we know that this fraction bar is 8/10. So if we have 8/10, 1, 2, 3, 4, 5, 6, 7, 8, we have 8/10. We can see here in this picture, we only have 2/10 that are missing. Okay, so we know that 2/10 is what would go there. Another way to think about it would just be out of 8/10, what's going to get us to a whole? And we know that one whole in this fraction is equal to 10/10. So the whole is equal 1 is equal to 10/10. And so we just need to figure out how we get from 8/10 to 10/10 and how many we need to add, and that's just 2. And it could just be 8/10, and if you wanted to do it as a unit fraction, you could say 8/10 plus 1/10 plus 1/10 is equal to 10/10, which is equal to 1. So there's a few different ways that you can look at it, and honestly, just being able to visualize like you can here really makes it easy. And remember, there's multiple ways to solve them, and I want to just introduce you to those different ways of looking at them and find which one works best for you. Number 10 is the same as number 9, same type of problem, and I want you to work on that one on your own. You can rewind this video and watch me do number 9 again if you kind of feel a little confused. And we're going to go ahead and look at number 11 together. And number 11 says 1 minus 3/4. Well, when we look at 1, we know that 1 as a fraction, in this case, because we have a denominator of 4 here, we know that 1 can be written as 4/4 here minus 3/4 is equal to, and then all you have to do is subtract straight across. Remember, in addition and subtraction, once you have your common denominator, which you have your common denominator here, they're both 4s, it stays the same, so your denominator remains the same. And then you just have to subtract straight across, and 4 minus 3 is equal to 1. Another way that you could look at that is if you wanted to draw yourself a fraction bar and break it up into 4 pieces, because you have one whole, and that one whole is equal to 4/4. So you've got one fraction bar, and it's broken up into 4 equal pieces. If you have 4 pieces and you're going to take away 3, 1, 2, and 3, how many are you left with? Well, you're left with 1. So there's a way to visualize it. Once you complete numbers 2, 3, 4, 6, 7, 8, and 10 on your own, please make sure you attach them to your assignment and turn them in. Thank you.